Okay, class, welcome to Eureka Math Module 2. This is Lesson 1. We're ready to start Module 2 after finishing Module 1. The title of Module 2, Lesson 1 is Why Move Things Around? And you will need pages 1 through 9 of your Module 2 book for this. This whole module is about geometry and movements and changing shapes. So let's start with some concept development about moving things around, seeing how movements can change some figures and keep some things the same. So this is a page I have. You do not have this page, but this is what we're going to go through together. You can see the first one says, given two segments, A, B, and CD, which could be very far apart. We do not know how far A, B, and CD are away from each other. Perhaps these are two roads hundreds of miles apart. Perhaps it's two paths of satellites in space, very far apart. How can we figure out if they are the same length without measuring them individually? So I know you could take a ruler and measure them and see if they are the same length. But what if you don't have a ruler? How else could you do it? Do you think these are the same lengths? How do you check? Well, let me show you one way to check using a transparency. Transparency is a little plastic sheet of paper. Really, any clear plastic will work for this. If you have a transparency, you can use a transparency. Or you can use a clear plastic bag. If you want a transparency, make sure you reach out to me so that I can get you a transparency to make, because transparencies will make some things a little bit easier for Module 2. And I have a pile of transparencies for anybody who wants to use them. So to see if these are the same, I'm going to very carefully trace AB. And I'm going to even trace the letters so I know where they are. Trace everything. And then, instead of using a ruler, I have AB on my transparency. I can just slide it over here to see if it matches. And yes, it does match. So if I trace it and slide it, that is one way to know that AB and CD are the same length. I can do the same thing with this rectangle right here. I have quadrilateral ABCD where there are four angles where there are four right angles, are opposite sides AD and BC of equal length. I can use my transparency, can grab a dry erase marker, and I will trace AD very carefully to make sure I'm being exact. And then I can slide it over and see that AD and BC are the same length. So it works for this strategy works for straight lines. Sliding and checking works for straight lines. It can also work with angles like I have right here. I have two angles, angle AOB and angle AOB prime. This little mark here, by the way, this little apostrophe in geometry right now, that means prime. It means we've moved it once. One apostrophe means it's moved one time. So the question is, can I tell if they have the same degree without measuring them with a protractor? Can I see if this angle right here and this angle right here are equal? Well, I get my transparency again, and I trace it carefully. I trace the angle very carefully, angle AOB, and this time I have to slide and spin, and after I slide and spin, I can see that they line up perfectly. So it is the same angle. So sliding works and spinning works. To see if lines are the same, to see if angles are the same. We can even do it when we have a shape like this. This is asking us, how can we tell that angle A and angle B have the same degree? Well, this is going to be a little bit different. Watch how I do this one. For this one, I'm going to trace everything. I'm going to trace the parallel lines. I'm going to trace the intersecting line. I'm going to trace my angles, and I'm going to label them A and B. Now this, the trick for this one is how do I make sure A lines up with B? Well, I'm going to twist it. I'm going to spin it. But I'm going to spin it around that point right there. So I'm going to keep that point right on the middle, and when I spin it, if I get my pens out of the way, after I spin it, I can see that A and B match and B and A match. I just spin it around a point. So these are some strategies to show that things are the same. So let's talk about some vocabulary that we use when we do this. Let's go back to our note page, and remember, you are following along with the notes with me, please. So we did our concept development. You saw the use of the transparency. You saw how useful that can be. So what we're doing, what I was just doing with the lines, with the rectangle, with the angle, and with the parallel lines, we are checking for something called congruence. We are checking for something called congruence after we do some transformations. So there's two vocabulary terms in what we were doing. We were checking for congruence after transformation. So let's talk about what these two vocabulary words. Now, congruence, what were we checking in that little activity there? Well, we were checking to make sure that the lines and the angles were the same shape, that a line was the same line, and we were checking to see that they were the same size. So that's what congruence means. Congruence means same shape, same size. So when we were checking with the transparency, we were checking shape and size. We were checking congruence. After a transformation. And a transformations is a fancy word for changes. So what we were doing with the transparency is we were checking to make sure the size and the shape stayed the same after we changed some things. More specifically, after we changed the location. Were the size and the shape the same after the changes? So that is what we were checking. And today, we're going to focus on 3 types of transformations. We will introduce 3 transformations that keep congruence. 3 changes that keep the same size and shape, that do not change size and shape. These transformations that keep the same size and shape are called rigid motions. Rigid motions is a third vocabulary term for changes that keep the same size and the same shape. So you have 3 vocabulary words right now. You have congruence, same size, same shape. Transformations are changes. Now, rigid motions is when we change something, but the size and the shape do not change. We change something, but the size and shape do not change. So let's talk about these three rigid motions. And so I'm going to build a tree map. Three rigid motions, so I need three branches of my tree map. And today we're not going to get to technical terms. I already gave you three vocabulary words. Let's keep it simple. The three rigid motions that keep congruence are a slide, a flip, and a spin. Now I can slide something and the size and shape stay the same. I can flip something and the size and shape stay the same. And I can spin something and the size and shape stays the same. Those are the three motions that keep congruence. So for example, I like to draw pictures. Drawing pictures helps. If I slide something over, and you can see same size, same shape. All it did is it moved to a different place. And it can also flip something. If I flip this, that's my little symbol for flip. You can see I just flipped it over. I flipped it. It's still the same size, still the same shape. It still says flip. It just flipped over. Still the same thing, it just flipped over. Spin. The spin goes kind of like this. Same size, same shape. I just made it spin. So there's a slide that keeps congruence, a flip that keeps congruence, and a spin that keeps congruence. Those are the three rigid motions, three transformations, three changes that keep the same size and shape. Let's practice this a little bit with some activities. So I'd like you to go to page 1 in your math book. Looks like that with the four whistle things or the four wheels. And we're going to try to figure out, we're going to describe what kind of transformations we're using. How to go from the original, and this is the original right here. How do we change the original to make number 1? How do we change the original to make number 2? And how do we change the original to make number 3? So to do this, what I'm going to do first is I'm going to take the same transparency I used at the beginning, and I'm going to trace the original. Now, if you have a piece of plastic, you can use this. Some of the activities we do in Module 2 are going to be a little bit tricky. That's why if you need a transparency, if you need a piece of plastic, please ask for one so that you can have any tool you need to make this a little bit easier. So I just traced the original. Now, how do I take this original? What do I need to do to make it line up with number 1? If I want it to be number 1, you can see, well, it's the original and number 1 facing the same direction. They look almost the same. So all I have to do is I use rigid motion number 1. I just slide it up and to the right. Just slide it up and to the right. So for number 1, how do I transform it? Number 1 is a slide. That's all you need to write. Number 1 is a slide. You don't even need to write directions today. Now number 2 is going to be a little bit more complicated because you're going to see the tail, or whatever you want to call it, is facing a different direction. So a slide will not make it line up perfectly. Even if I slide it and spin it, you can see spinning it will not make it line up. So I have to use a different way. What I have to do is I have to flip it. So what I'm going to do is I'm going to flip the original so that it's like that. And then after I flip, I slide. So let me show you that one more time. Here's the original. I have to flip it so it looks like that. Flip it over this line. Flip it over this line. And then slide it. So how did I do number 2? It was a flip and a slide. Now, some of you who are paying extra attention might say, Mr. Baird, what if you slide first? And I'm like, yeah, that'll work, because what I can do is I can slide it like this, and then after I slide it, then I flip it over. So for number 2, you can do a flip and a slide, or you can do a slide and then a flip. For this transformation, it does not matter what order you do it in. Now let's check number 3. Go back to my original. For number 3, you can see if I slide it, it's still not going to be perfect. A slide does not make it line up. So what I have to do is I slide it, and then I spin it. No flip this time, a spin. A slide and a spin. Or some of you who want to be a little bit creative might do a spin first and then a slide. But you need to do both. So for number 3, you can do a slide and a spin, or you can do a spin and a slide. And hopefully you're having some fun with this. Hopefully you're getting used to moving things around on paper using a transparency if you have one, because we're going to be doing this a lot in Module 2. So it requires some creativity. It requires a little bit of patience. It requires just a tiny bit of artistic skill, but it requires a lot of thinking in different dimensions to see how to make the changes, how to make the transformations. So you need to practice on these easy ones so that when it gets a little bit more difficult, you are prepared. Let's go to the next page, page 2. And you'll see this time we have lines, and it's asking, how do you check to make sure these are the same if you don't have a ruler? Well, this is the exact same activity we did kind of together on the concept development. So what I'd like you to do is I'd just like you to explain in your own words how you make this one match this. And pause the video, write it down in your own words how you give me the evidence, and then come back and we'll talk a little bit. Okay, now you should have remembered that how do you prove this? Well, first thing you do is you're going to copy AB like this. Copy AB. Sorry, mine was a little short. And then how do you make it match? Well, you have to slide it and spin it to check. So it's you copy it, you slide it, you spin it, and then they are the same. Or to use the vocabulary word, they are congruent. So what we do is we copy AB onto another piece of paper or a transparency. We slide and spin to match CD. And then our conclusion is when they line up perfectly, they are congruent. Or if you want to write it in mathematical symbols, you say segment AB, which is AB with a bar, segment AB is congruent, that's the symbol for congruent, with segment CD. So this says segment AB is congruent to segment CD. That's how you write it with symbols. So pause it, copy down those symbols so you know how to do them later, because they will come back. Next page is a little bit of a summary of the lesson. The page after that is your homework helper. Well, actually, I think the page after that was the exit ticket, but I'm skipping the exit ticket for right now. You're going to actually do the exit ticket later. So put the exit ticket aside. You're going to need it after you do the problem set, because here is the problem set. We're going to do the problem set before the exit ticket. For the problem set, it's asking you to use as much of the new vocabulary as you can to describe what you see in the diagram below. So what we're going to say is segment AB slides to show, and here's our vocabulary word, to show congruence with segment F of AB. So it slides to show congruence because we just slide it over. We can just slide it over. Sliding shows congruence. Sliding shows congruence. Now, number 2 is going to be a little bit trickier because we're not talking about a line or a simple shape. This is a little bit more of a complex shape. And so what kind of transformation is required from the original to the image? So I want you to try to figure this out. The answer will be online, but I would like you to figure out what transformation, or is there more than one transformation that will move this over here. So a good first step is to take this and to trace the star, making sure you are very careful about tracing it as exactly as possible. Even the dots you need to label, and then play around with it and try to see, like a slide obviously won't work. So it has to be a slide and something else. So what is it going to be? What is it going to be? Try to figure it out. You can check the answers online, but play with it with your transparency or with your piece of plastic or with another piece of paper. How do you make them match perfectly? What transformations do you need to use? The answers for that will be online. And then the last thing you're going to work on today is the exit ticket. The exit ticket says, first draw a simple figure and name it figure W, which means you can draw whatever figure, whatever shape you want and label, and just you have to give it the name W. So my last name starts with a B, so I could just say, this is my figure. It's going to be figure W. Now, draw its image under some transformation. I can do whatever transformation I want to move my figure W. So you are going to draw any figure you want. Could be a letter, could be a shape, could be a smiley face. After you draw the figure, you are just going to move it some way. You're going to follow either a slide, a spin, a flip, or more than one of those. But I just want you to move it some way, move it somehow. and then explain how you moved it. Tell me the order you did things in. Did you do a slide, a flip, and a spin? Did you do a spin and a flip? Did you do a flip and a slide? How did you move yours? This is why everybody's exit ticket is going to be different. So I want you to pick a figure and move it, and then tell me how you moved it. And then today I'd like you to take a picture of your exit ticket using either a phone, a camera, or the camera on your Chromebook will do it. But you are going to take a picture of your exit ticket and then turn it in on the Google Classroom for the evidence that you completed today's work. So that is what you need to do today for the exit ticket. Draw a figure, move your figure, tell me how it moved, and then please turn in a picture of your exit ticket. And I will see you tomorrow for Module 2, Lesson 2, when we increase our vocabulary just a tiny bit. Have a good day.